Today we're going to be working on binomial theorem. And in order to do that, we need to recall that a binomial is a polynomial that has two terms. In this section, we will study a formula that gives us a quick method of raising a binomial to a power. So we'll start with x plus a to the 0 power. So this is a binomial raised to the 0 power. Now anything to the 0 power is 1. So we've got that. Now let's do x plus a to the first power. And so when we get this to the first power, that would be 1x plus 1a. Now if we did x plus a to the second power, remember x plus a to the second power means x plus a times x plus a. And so we would FOIL that. X times x gives us 1x squared. X times a gives me 1xa. A times x gives me 1xa, and a times a gives me 1a squared. I combine my like terms and I get 1x squared plus 2xa plus 1a squared. If we went to x plus a cubed, we would do x plus a times what we just got right there, since we just did that one. And then we would go ahead and distribute this x to everything in there and this a to everything in there. So we get 1x cubed plus 2x squared a plus xa squared plus ax squared plus 2xa squared plus a cubed. And I'll write it over here so that we've got it together. And so that's going to give me 1x cubed plus 3x squared a to the first plus 3x to the first a squared plus 1a cubed x to the 0. We can continue this pattern on, but it's going to get really tedious as we start multiplying these out. So this pattern we're going to study helps us to do this without having to do all that multiplication out. So we're going to point out a couple of patterns here. We've got a 1 here, here, and here. And then it goes 1, 2, 1. And then it goes 1, 3, 3, 1. And that's what we want to show you on this pattern. So let's look at that. That pattern you were just looking at, we call Pascal's triangle. There's a convenient way to remember the pattern for binomial coefficients. By arranging the coefficients in a triangular pattern, you obtain the following array, which is called Pascal's triangle. This triangle is named after the famous French mathematician Blaise Pascal, 1623 to 1662. So here is our Pascal's triangle. It is 1. And then that second pattern that we were just looking at was 1, 1. And then 1, 2, 1, 1, 3, 3, 1. The next row would be 1, 4, 6, 4, 1. The way this is happening is this comes down here. And then these two create that number right there, and it comes down right here. Then these two are going to create that 3, because 1 plus 2 is 3, and 2 plus 1 is 3, and the 1s just come down. Then we've got 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. And we continue by adding these to get the next column. So 4 plus 6, 6 plus 4, 4 plus 1, and then a 1 at the end. We'll go ahead and create the next row here just so that you can see how that works. And so in our next row, we would have the 1s on the outside. Then we would add these two together to get 6, add these two together to get 15, 20, 15, and 6. And so that's going to give us each row. That would be our row 6. This right here is the coefficients that we just saw in our binomial expansion. So we can easily expand if we know that portion of the Pascal's triangle. So we're going to look at this one right here, and it says write the expansion for the expression of x plus 2 to the 5th power. We would not want to multiply x plus 2 times x plus 2 times x plus 2 5 times. That would get tedious. But if we use this pattern, we start with this part right here, row 5. And so we're going to want to use these coefficients right here on row 5. 1, 5, 10, 10, 5, and 1. That's our row 5. That's what we're going to use for this one. And so we're going to set that up. 1 is my first coefficient. Then you take this term right here, and it is going to start with x to the 5th. So I'm using that same 1 right there. And then I multiply it times the second number in our binomial here, and it's going to start with 0. And so for our pattern, our next number here is a 5. And then we go 1 less on this one, so this would be x to the 4th, and we would go 1 up on this one, so this is going to be 2 to the 1st. We keep going, so our next coefficient is 10. And then we go x, 1 less, that's 3. And then we're going to go 2 and 1 up from that one. Our next coefficient is 10. And then we go x, 1 less, 2, 1 up. Our next coefficient is 5. Then x, we're going to go 1 less, so that's x to the 1st. 2, we're going to go 1 up, so that is to the 4th. Our last one is going to be 1. And that's x to the 0 power and 2 to the 5th power. So notice that our exponent here started with that first term, and it went down 1 on each one of these until we got to the 0. On the second value here, which was 2, it started at 0, and it went up until we got to the top one of 5. Now we're going to go ahead and simplify this. Anything to the 0 power is 1. So 1 times x to the 5th times 1 is x to the 5th. On the second one, that would be 2 times 5, which is 10 times x to the 4th. This third one, 2 squared is 4 times 10 is 40 x cubed. When we work on this next one here, we got 2 to the 3rd power, which is 8 times 10, which is 80 x squared. Here we've got 2 to the 4th power, which is 16 times 5 gives us 80 again, x, and then 2 to the 5th power is 32. This one's not going to have an x because anything to the 0 power is 1, and so we quickly expanded that instead of having to do the multiplication of x plus 2 times itself 5 times. Let's give another one of those a shot. So we've got x minus 2y to the 4th power. So my exponent here is 4. So I'm going to be using row 4 of Pascal's triangle. Row 4 was 1, 4, 6, 4, and 1. So those are going to be my coefficients. When I set this up, I'm going to go ahead and put my 3 parentheses in each one. I've set up 5 of those with 3 sets of parentheses each, and that's because I've got 1, 2, 3, 4, 5 coefficients. And so I'm going to start with those coefficients: 1, 4, 6, 4, and 1. So I've got Pascal's triangle now in each one of those first parentheses. Then I go with my first term there, x. So there it is. And I start with the same exponent as that. So that's going to be x to the 4th. Then I go 1 down on each one. So that's going to be x cubed, x squared, x to the 1st, and then x to the 0 power. Then I get my second term. In this case, that is a negative 2y. So I'm going to put a negative 2y there to the 0 power. negative 2y to the first power, negative 2y to the second power, negative 2y to the third power, and negative 2y to the fourth power. Now we're ready to simplify. Anything to the 0 power is 1, so this first term is just going to be x to the fourth. In this second one, I've got negative 2y to the first power, so that's just negative 2 times a positive 4 gives me a negative 8, and then we've got x cubed and y. For our next term, we are going to take negative 2y and square it. Negative 2 squared is a positive 4 times 6 is 24, so that's going to be the coefficient there. And then I've got an x squared and a y squared. For my next one here, I got negative 2 to the third power. That's going to be a negative 8 times 4 gives me a negative 32. So probably shouldn't have written that positive there. So negative 32. And then the x is to the first power, and the y is to the third power. And so for my last one here, and I scratched that out, so make sure you see that scratched out. Negative 2 to the fourth power gives us a positive 16 times 1 is a positive 16. X to the 0 power is just 1, and then I've got a y to the fourth power. So there is our expanded form. We didn't have to do all the math of multiplying x minus 2y times x minus 2y times x minus 2y times x minus 2y. All right, if you think you're ready to try one, go ahead and pause it and try this one on your own. I'll go ahead and show you another one if you want to see another one. If you want to pause it, go ahead and pause it and then check your work. So this one's going to be row 4 again. So we're going to use that 4, 6, 4, and 1 again. The easiest way for me is to go ahead and set up those 3 parentheses, and we want to do that for each one of these. So that's going to be 5 times. One, 2, 3, 4, and 5. Perfect. And so now I put my coefficients. And so there's my coefficients from the Pascal's triangle. And then I put my terms. And so 2x, 2x, 2x in each one of those. I start with the same exponent. So that's going to be 4. And then I go down 3, 2, 1, and 0. Then I put my second term, which in this case is 3. And that one I'm going to start with 0, and then it's going to move up. So 0, 1, 2, 3, and 4. Now we're ready to simplify. This first one's going to be the easiest. 2 to the fourth power gives us 16 times x to the fourth power. For the second one, we've got 3 to the first power, so that's going to be 3. 2 to the third power, which is 8. So 3 times 8 is 24, times 4 is 96. And then we have an x cubed there. If you need the calculator here, you could use the calculator as well, since this is going to be the calculator portion of the test. So 3 squared is 9, times 2 squared, which is 4, times 6 is going to give us 216x squared. And then we're going to go ahead and multiply 3 to the third power, which is 27 times 2 times the 4, which is going to give us 216 again. And in that case, that's just x to the first. And then we're going to go ahead and do our last one here. 3 to the fourth power is 81. 2 to the 0 power is still 1 times 1, so that's going to be 81. And with the x to the 0 power is 1. And so there is our binomial expansion. If you haven't tried one yet, make sure that you pause the video here and give this one a try, and then come back and check your work to make sure that you know how to do it correctly. In this case, this one is row 3. And so I would take row 3, which is 1, 3, 3, and 1. So I need 4 setups here. So I'm going to take my 3 parentheses, and I'm going to do that 4 times. I start with my coefficients, 1, 3, 3, and 1. My first term here is x squared now, so this is going to be x squared in each one of these parentheses. And then our exponent there is going to be a 3, so I'm going to start with 3 and then go down from there. My second term is a 4, so I'm going to put a 4 in each one of these. And that one starts at 0 and goes up, so 0, 1, 2, and 3. Now we're ready to simplify. In this case, 4 to the 0 is 1, and 1 times 1 is just 1. Here we've got a power to a power, so you multiply those. So that's going to be x to the 6th power. This is going to be 3 times 4, which is 12. Oh, I forgot the negatives on there. Sorry, please catch that. Those 4s are negative. So 3 times a negative 4 gives me a negative 12. And then that is a 2 raised to the 2nd power, so that's going to be x to the 4th power. For our next term here, negative 4 squared, that's 16 times the 3 is going to be 48. And then the x squared to the 1st power is just x squared. Our last one here, we've got negative 4 to the 3rd power, which is negative 64. And since the x is raised to the 0 power, 0 times 2 is 0, and x to the 0 power is 1. So that would be our binomial expansion. Make sure that you can expand those so you don't have to do the extra math multiplying everything out.